Okay, maybe we can start. Okay, so my name is Nicolas, and I work at INRIA and Laboratoire d'Informatique de Grenoble, which are two computer science research institutes. I work as a R&D engineer, and specifically on human-centered experimental platform, which I will explain later. In this talk, I will speak about openHAB. I said it's Eclipse Smartome, but it was basically a project on itself based on Eclipse technology, and it's openHAB became the first contribution to Eclipse Smartome. So I'm not a developer of openHAB or Eclipse Smartome. Is there anyone in the room that is a contributor of openHAB? No? Okay. But it's not my work. So I will often use openHAB, but you can hear Eclipse Smartome. Okay, so I work in a research institute on computer science, and for the last years, the idea in the lab was to put the user back in all the processes. Because you have too much projects. They get their fundings for 3 years. They have an idea. They work 3 years. They spend money on engineers, on a lot of things. And after 3 years, they have a product or they have a thing. And when it comes to users, they say, no, we don't want this. It's not good. So they lose basically 3 years and a lot of money. So the idea is to include the users at every part of the project, so they can contribute to the ideas, and the iterative loop is important because you have an idea, you can test it right away and make a change in consequences. The other idea was to work in transdisciplinary disciplines. So we are computer science, but we work with a lot of human sciences, like sociology, economics, and all the kind of things. And the idea is also to mix academics, private sector, students. So to do that, we have fab labs. So a lot of machines to do prototyping. So when you have the idea, you can prototype it right away with 3D printers, with laser cutter, and test it right away in the project. To test the product and to make the co-creation, we have this platform, for example. It's called the Domus platform. You can see that there are a few experimentation rooms. There's a big plateau d'expérimentation, where you can make creation meetings with users. So you register what they say and you try to come up with something interesting. There's a control room, régie, where all the data from all the room can be retrieved, like cameras, microphones, and data from sensors or things. And you have a flat. It's called the appartment Domus. And it's a realistic, functional flat. It's 40 meter square. It's fully equipped with sensors, actuators, and it's made to test prototypes, to test ideas in conditions that are really close to the reality. So we put a lot of things in this apartment. So microphones, cameras, robots, RFID, the sensors, movement sensors, temperature, humidity, water consumption, smart outlets, lamps, and you can see that there are a lot of different protocols, and all those protocols don't speak naturally to each other. So we need to rule all those protocols for the experimentation and for the show. So for the experimentation, we have very specific needs. We need to retrieve all the data. We need to timestamp them. We need to store them in databases or things. We need to make them visible. We need to have reliable sensors. We can also need to launch specific scenarios during the experiment. These things are specific for experiment, but they are really close of what you want to do when you build a smart home. And for the show is the other part of being in a platform. So you do experiments, but in the time that you are not experimenting with people, you have to show the platform. You have to scientists, to students, to partners, to show them what you can do with it and why it is important, and so they want to come and they want to have new ideas and create new things. I will talk about openHAB just later. My first experiment as a developer on the platform was when we have a domotic protocol called KNX, which can control lights, and we had Xbox with a UPnP server on it, and we had a RFID reader. And they said to me, okay, make a demo of all the things working together. So I was young, I had no idea of what those, so I took my Java IDE classical, and I found a few Java libs for the protocols and made big main class horrible with all the things. And a few weeks later, I had a good demo, and when we used the RFID tag, there was music, there was lights, and it was cool. But it was not really resilient, it was not really evolutive, and a few times later we had a PhD student which he installed middleware from a private company, and it was better because a few protocols were already implemented in it. We could mix the protocol quite easily, but we had a lot of downside, like all the scenarios we could think about. We had to write them in a Java class, and each time we wanted to make a change, we had to compile it with Maven and deploy it in the middleware. So just sometimes to change from 10 to 5 in a scenario, we had to take 5 or 10 minutes. And one day we came across openHAB. So again, I'm not part of the team. I'm just a very enthusiastic user of it. Okay, this is architecture overview. I don't like it, it's too complicated. But basically, openHAB is a middleware to make your home smart. And the aim is that you don't want to spend hours developing or redeveloping protocols, libraries, or wanting or understanding how the library works to make your smart home appliances. So you use it. I'll try now to explain as a user how you can use openHAB. The first thing to know is that the most simple thing and the core concept in openHAB is the item. So the item, it's made to represent something existing in real life, like a sensor or an actuator, but it's not really linked to a real object, it's linked to the function of an object. So you have a few basic types, And with these types, you can do almost anything. I like this, I made this small graphics. It's a lot simpler than the reality, but the important thing here is the event bus and item repository. Each time you create an item, it goes in the item repository. And then each time there's a change on an item, there's an event on the event bus. To make the link between the real appliances and the item repository, you need to use bindings. So it's basically a jar, and you put all the stuff necessary to communicate with your device in it. And when an item is in the repository and in the event bus, it accesses all the cool things that are implemented in openHAB, like generated UIs described by a few lines of code, powerful rules and script engine, REST interface, and persistence services. So when you want to start with openHAB, you go on the website and you download the runtime. You extract it, you double-click on the script, launch script, and basically you have a lot of lines of code and it does nothing. The first thing you have to do is to configure your items, because all the items you describe are stored in files. So this is what the runtime is about. You have a folder for add-ons, so bindings, and a folder for configurations. In configuration, you configure the general openHAB configuration. You have a folder for items, a folder for the rules, a folder for the script, and for the sitemaps. So I will show you an example. So it comes with a nice designer based on Eclipse 2. So the first thing I did when I had to integrate KNX item was to add in the add-on repository, in the add-on folder, the good binding. And when you do that, you go on the website, you download the package where all the add-ons are, and you realize this community is completely insane, because in this package there are 125 bindings. And it's incredible. You have basically everything you can have in your house, from domotics systems to UV lamps, to even now you can control your Tesla electric car from the device. Okay, if it's in the house, there's a binding for it. So, quick example again from KNX. The first thing to do is to configure the gateway IP, for example, if you use the gateway IP for it. And then you can describe your first item. This is an example. You can see an item as a type we saw earlier, a name, a human readable name. It can be in groups. And then this part is the configuration of the binding. So here it says KNX and some string. So the system knows that it's a KNX item, so it sends this configuration to the KNX binding, and the KNX binding has some code to make it right. Okay, and once you do that, it's done, it's in the system. So what can you do with it? You can visualize a state. So this is a sitemap example. So you can see in describing just in a few lines, you can say, okay, I want on my page a switch, it's a widget, linked to this item. And so, just like that, when I go to the openHAB web page. You see it's called KNX because it's the name of my sitemap. And I have my kitchen outlet. So it's not linked to KNX because there's no KNX here, but it's the principle. Now, if I want to add a new item, I add it, I save. Oh, I should add it in the items first. So I add it in the item, and this one, you see, I didn't link it to a real item. But the system doesn't care. If it's linked to a real item, it's linked, but if it's not, it's an item like the other. And so we can use it in the sitemaps and in the rule. So if I go back here, it's here. And I can switch it on, switch it off, switch it on. So now that it's here, I can make a rule. So I'll make a completely dumb rule, for example. And the scripting language is really simple, but really powerful. So this rule is completely dumb. So when the outlet receives command on, I send command off to the outlet. So it becomes basically a useless tool. Okay, it's so fun. Okay. So yes, it was just a quick pick to see of how you can control openHAB and why is it fast to develop. Because you see, at the time I save my new configuration, it's already in the system and the rule is here and it's really impressive. So I integrated all the things that were in the flat with openHAB. So there's a binding for a lot of things in it, but not for everything. But since you can create virtual items, and that in the rule system you have a lot of action you can do, like sending orders to other systems, but you have also a lot of action you can add, like sending mails, HTTP requests, playing music. And there's basically unlimited possibilities. So I will show you. This is the current configuration of the apartment. So you can see there are a lot of items. This is only the KNX part with all the sensors in it, the rules, and okay. And for example, when you have something, we have in the flat sensors on the floor which detect if the people are walking, and it's something a guy made, and it's on Arduino. So we had to integrate it, but it was not easy because a simple way to do it was to use the REST API. Every time you create an item in the repository, it's in the REST API. So you can see I have my outlet 1 and my outlet 2 here. So you can get the state, and you can switch the state just with a basic HTTP request. So, and instantly. So it's very powerful. So way to integrate the floor sensors was this one. We created a few virtual only items, and in the Arduino code we said, okay, each time this item gets a new value, just send a post request on the API and the REST API, and it will be like if it was with a binding, and it works perfectly. Okay, so now well, that was a very fast explanation. If you want more, you can come to me or go to the website, because it's really, there are really good explanations. There's a big community. They always answer all the questions. There are a lot of tutorials. It's really interesting. So now I want to show you, because when we have done all that, we started to have fun. because we had all those protocols interconnected, and we wanted to make everything smart. And the last thing we made smart was Panda Bear. This is real. This is not a cheated video. So basically, I just put a RFID tag on my Panda, a RFID reader in the table, and when I put my Panda in it, the light switch on, the switch off, I have a film for a few seconds, the roller shutters closed, and then the light gently fade. Okay, it's fun. Then I will talk about the Domus cube. So this is one of the things we made in a co-creation. So we had a few elderly people coming here, and we talked to them and said, what do you want in your house to make your comfort better? And they made a reunion, they talk, and they said, we want a cube, and when we put it on the face, it sends orders in the house. Okay, we can do it. So we used the 3D printer to make the box. My coworker made all the Bluetooth thingy to put it on a Raspberry Pi. And with MQTT, we could connect openHAB, because there's MQTT binding, obviously, connect the cube to the openHAB server, and then send some scenario. Okay, and it's basically the same just used with the Panda. And this was fun because when we did that, we kind of split the work between my coworker and me. So it spent hours in Bluetooth, in MQTT, and then I came and said, okay, I need to integrate this in openHAB. So I had the binding, I had one line in the configuration to put the address of the server, one line to declare an item linked with the topic, and I write my rule, and it's done. So basically, I won. So okay, we have all these kind of things, and it's fun. We have a showroom, but now we can experiment. So the first experiment was made was with a little robot. So here the home control is not relevant. It's not what is tested. It's just used to make we make the people believe that the robot can control the apartment. And what is really tested is how the people can be attached to the robot, because the robot at first don't say anything, and time after time it starts doing little noises, and then to speak a little. So we had to make the people believe that the robot could control the apartment. So in the control room, you can see me here with my Xbox controller controlling the robot. And we built Wizard of Oz interface. So Wizard of Oz is a technique we use in this kind of platform. It's basically the fact to make the people believe that a system is working before developing it. So, and you know it's complicated to develop good vocal recognition on the robot, and so we all did with the Wizard of Oz. So this interface was here to control the robot movements, and we wanted it to be able to simply control the apartment. Okay, we have a REST API. We just send command to the REST API, it's simple, and we can integrate the thing and do the experiment. So this is a small video of the people using it. So she'll ask him to light the...
Oh, il faut mettre de la lumière.
Okay, she asks for the light.
Oui, la lumière.
And he puts the lights on.
Ça va mieux, oui.
Okay, so it's...
c'est super.
It's an example of use. So in this thing, all the intelligence is in the outside program, but it's still simpler for the people that make the experiment because they have one thing to implement, and it's a post request, so it's not complicated, instead of doing KNX and all the other protocol. Another experiment we made was with brain-computer interface. So a PhD student came to me and said, yeah, I have a thing with this computer brain, and I make the people play Doom, I make the people fly drones with it, but I want to control the house with it. What can we do? Okay, it's easy. So she came and she had all her algorithms, and she was able to recognize if people say roller shutter or a cup or TV. And so I said, okay, I created for her an item, virtual, which was a brain-computer interface status. And all she had to do was to send a post request to the REST API to change the status. And then it was in the rule engine, so I made a few rules very fast. When I'm in the room and I get roller shutter, if the roller shutter is open, close it, and those kind of things. And so in a few hours, she was able to control the apartment with the brain. And it really works, and it was quite impressive and quite cool. So I will show you a video. The first part of the video is completely fake, but it with a good camera. And the next part is with shitty cameras, but it's real. So, and it's lucky, I don't know why. Okay, so she controls the TV with the brain. This part is real, and she was really thinking about lights, about roller shutter, and it really sent the orders to the apartment. And we even made experiments with disabled people, which was it was the first time we did it, and it was really interesting because that people were really interested in this kind of technology, for example. So it's cool here is that a few years ago, the person using it wouldn't have a brain-computer interface, but that's not the problem. It would have been very complicated for her to make this experiment at a technical point of view. And then she was on the platform, and in really a few hours, we implemented all the things. So she could not spend time focusing on technical, recruiting engineers, and other things like that. All is done, so she just had to experiment. Later, and we built a new apartment, so it's bigger. It's 90 meters square. It's a duplex. So we installed it just 2 weeks ago. But I still I had some time to install some sensors in it. And a thing I did is I integrated KNX completely different. When you integrate a bus in home automation like KNX, KNX is basically a wired bus, and it links all the appliances of your apartment. So you can program the button to speak to the outlet or the lamp or the thing like that. And you program it like that, and when you come with openHAB, you're over it, because you don't want that when your server is down, the apartment is down. But since openHAB is really reliable, and I wanted to try it, so I just configured it so the KNX only speaks to the openHAB server. And all the rules that I make are in openHAB. So then I realized I had 48 buttons, so I had to write 48 rules. So I made a small code to generate the rules, because it's easy to write. You've seen it. And I started having fun. So you can control the light. You can see on the roof there are music which can be played. So basically, if you click on the end, on a button like is here, you have Barry White in all the apartment. quite fun. And we can start imagine a lot of things, because if all the rules are in openHAB and it's easy to change it, and change it on the fly, you can imagine even changing it within openHAB. Since you can write, you can send bash command in the rules, you can write the own rules in the rules and change things like that. You can think of using Git to switch from a configuration to another. And it's really interesting. I think it will occupy my summer to test things like that. Okay, but now we've seen platforms, and we will stop with platforms, and we'll pass, because it's cool to, when people come to the apartment to make experiments, but it's really more interesting for scientists when you go to the people to make experiment at their house, because it's more ecological, it can last longer, and the data are better. So in the project, we have something called the mini kit. So basically, it's a suitcase with all sensors we can find, we can buy, which are useful for the experiment. If we don't find it in off the shelf, we can do it in the Fab Lab. And you go to the people and you put all the sensors everywhere in the apartment, and you need to have a gateway which centralizes all the data and stores the data so the scientists can use it later. Okay, what can we do with that? openHAB. So the first I made was for scientists who wanted to test conceptions. So I had those Z-Wave, it's a protocol for home automation, wireless, plugs that send the consumption of the objects that are plugged in it. He wanted some sensors from luminosity, contact, so I had Z-Wave, things like that to see. In openHAB, you have a binding for Z-Wave, so it was really easy to integrate. He wanted to add Yahoo weather forecast. There's a binding for that, so I added it. He wanted that the data went on MongoDB, and I don't remember the other SQL database. There's a binding for that too. So basically, all I had to do was to write some scripts to make this thing happen. And the interesting thing is that I made it on my laptop, this one on Windows 7. And when I wanted to put it on the Raspberry so it can be a mini kit, I just took my runtime openHAB folder, I put it in the Raspberry as is. I just changed the port number because it was not a COM-X, it was the FTTY USB-Y, USB, okay. And it works on the first attempt. And it was really impressive. Okay, so we built two other mini-kits that I want to show you, because the DomiCube we saw earlier, we created with the people, we integrated in the apartment to test it, and the next part was to test it at the people's house. So the first elderly people we worked with wanted to control the music with it. So we integrated quite nicely, I think. And, and with the rule, we could control a small XBMC server to make music. And an interesting thing was with only the rules, because the cube just sends the information of the face is in it and of the orientation it takes. And since the people said, okay, I want, if I do a slight movement, it changes the song in the playlist, and if I do a big movement, it changes the playlist. And just with the rules, with timer, and we can do complicated things like that. And so it was really cool. The other people we worked with wanted, so he had 4 things he could control with his cube. So for 2 lamps, 3 lamps, and 1 plug for his music. And he said, okay, I want to define for each phase what state the appliance will be. And he wanted to be able to change it during the experiment. So a tricky way to use openHAB was to say, okay, I create 1 virtual item per phase and for each appliance. And you can add it to the generated UI. When you click on it, it saves the new state. With the persistent system, you can save it and even restore it at startup. And in the rule, you say, okay, when it's phase 1, you go to see the state of phase 1, lamp 1, and you put it in this state. And if it's undefined because the people wanted that it was undefined, it doesn't change anything. So it was an interesting way, I think, of using the rules to make what we want without developing real codes. And the last thing I wanted to show you, it's basically because of this I couldn't prepare this talk much. 1 week ago, the people that made the experiment with the robot called me and say, okay, we have a big demonstration at InnoRobot. It's a French conference about robotics in Lyon, and they have a smart home demonstration. We need you to make us a mini kit. We should have in it a door where we can open, a ring bell, and a few appliances we can control. And we need to have a human interface to make the Wizard of Oz technique I talked to earlier. And the people which made the experiment with the brain-computer interface will be understand too, and will have to control all the things with the brain-computer. Okay, so we had 5 days to do it on top of everything else. And so I don't know if you can see, but for the appliances, it was not really complicated. We had the wave things, so it was really, we already did that. Then we had to control the music, but in openHAB there is an action you can use in the rules to play a wave file. So it was easy to integrate too. She wanted to have a button for the ring bell and a LED, because she said, oh, people will not hear the ring bell, so you have to put a LED so the people can see that it rings. And so, okay, I use my board and the GPIO of the Raspberry, and there's a binding for that, so it's simple. And the last thing, but the hardest, was to control to make a door and to control it. So we had 2 trainees to do it. One was modeling the door and all the things that make the door works. And then we used the laser cutter and the 3D printer to make the real box and the door. And another trainee was working with servo motors. So we said, okay, we will use that to open and close the door, but since it's too complicated to integrate, just make me a script, open the door, and a script, close the door, and with the rules, I can just, since I can use a bash command, I will call the script, and all will be fine. And this is the result. So you can see the generated interface, and so with a few rules, a few integration, and nearly no code at all. We were able to build that in just a few days of work. Okay, this is it. So I know it's a little special because I'm not really a Java contributor or developer, but it was my experience with Eclipse Smart Home. I hope you like it. And if you have a question, go ahead. No? Yeah?
When you have this long list of rules like this,
Yeah.
I imagine it must be quite challenging for the user to not get confused with all that, you know.
Yeah, but I'm not. It's not made for user. I think yes, for user it's complicated, and openHAB is not really ready for end user. I think.
No, I mean, you know, I can imagine myself being extremely confused if I enter this apartment.
Oh.
Everything reacts in an
Yeah.
unexpected way. You know, how are you going to teach people regarding how to use it, right? You know?
We adapt to the experiment, and since we have this configuration you saw is the showroom configuration. When you're in experiment, you remove the file or you rename them, and if you just rename them, they are not taken into account. So we change a lot of this to adapt to the experiment. No question? Okay, thank you.